Okay, we're going to do problems 11 through 14. I think everyone will agree that problem 11 is the simplest. So for what x values is the function positive? Select all that apply. So I'm going to start with negative 5. And I'm going to use an open circle because it says less than negative 5. It doesn't say less than or equal to negative 5. There are no greater than or less than symbols in this whole montage, so whole time I'm just going to use the open circles for problem 11. And then we have, would be negative 4, negative 3, negative 2, negative 1, 0. I'm going to use an open circle there. And then positive 1, positive 2, positive 3. That's one of our values. And then positive 4. So that's negative 5. This is 3. This is 4. Sorry, that's 0 here, 3 here, and 4 here. And then right here in the middle, we have 3.5. Okay, so anywhere that's positive, we could mark in green. See, between 3 and 4 for D, that's positive. Between 3 and 4 for C, that's positive. For B, which is between 0 and 3, that's positive. The only thing that's really negative is between negative 5 and 0. A does not check out, but D, B, and C do. Okay. So we could say D is right, C is right, B is right, but A is not. And then going back to block, just like Amy Winehouse said, we have y equals x squared minus 3. We're working with the vertex formula right now, so that's y equal to x. Technically, there's a here, which is the slope. X minus h squared minus 3. And so what that means in this case, a equals 1. Otherwise, we'd have something multiplied by x. And then x minus 0. Y equals 1 times x minus 0 minus 3, which is just 1 times x. Oh, and that's squared. Which is really just the same thing as this. As y equals x squared minus 3. And so to see y, let's do the parent function, x squared. The parent function of this is x squared, which should look like something like that. That's a little bit distorted, but it's going to look like a u thing. And we have 0, 0 times 0 is 0, negative 1, positive 1, negative 2, positive 2. Okay, so 0 times 0 is 0, negative 1 times negative 1 is 1, negative 2 times negative 2 is 4, 1 times 1 is 1, 2 times 2 is 4. So over here, and then that's the point of origin over here, and then 1, 1, negative 1 and 1, 2 and 4, 2 and 4. And that's the parent function. like that. And then what we're going to do is x squared minus 3. So if I substitute x for 0, 0 squared is still 0, 0 minus 3 is negative 3, so that's negative 2, this would be negative 3, and let's use red instead. Not that red though. Let's use this red. And then we've got negative 3, and then negative 1, negative 1. Let me pull that down a little bit. Zero, negative 3, negative 2, 1, and 2. So then negative 1 times negative 1, negative 1 squared is just positive 1. Positive 1 minus 3 is negative 2. Negative 2 squared is 4. 4 minus 3 is 1. Should have the same thing. This should be this, and this should be that. Let's make sure 1 squared is 1. 1 minus 3 is negative 2. 2 squared is 4. 4 minus 3 is 1. So it's the same thing. So then 0, negative 3, negative 1, negative 1, negative 2. Oh, we're going to use red. That red. And then 1 is negative 2. And then 2 is 1, and negative 2 is 1. So 2, 1, negative 2. Oh, that red is a little off. Negative 2 is 1. So then we have the same graph really. It's just transformed. It's shifted down 3 units. So that's all that is. And that's what happens in the vertex formula when you go down 3 units. This should be, vertex formula is a times x minus h squared minus or plus k. In this case, k equaled negative 3, and a equaled 1, and h equaled 0. So now we're working with the same idea, except it's absolute value. So we have y equal to a times absolute value of x minus h plus k again. And let's look at the parent function before we go into too much details. The parent function would just be, we'll go back. Okay. Second. Okay. Sorry, computer was freezing up for me for a minute. So we have x, and then we have absolute value of x with 0 here in the middle again. And absolute value of 0 is 0. And then absolute value of negative 1 is 1. Absolute value of negative 2 is positive 2. Absolute value of 1 is 1. Absolute value of 2 is 2. Remember, the absolute value of something is just saying how many steps, how many things are inside here, between the absolute value. So if you have negative 3, it's still just positive 3. The only exception is the absolute value of 0 is 0. Otherwise, anything inside the absolute value bars is going to be equal to its positive value. Okay. So then we graph that. We have 0 over here. And let's use blue, point of origin. And then we have -1 is equal to 1, +1 is equal to 1, -2 is equal to +2, +2 is equal to 2. See, this thing, the graph that we're matching the equation to is in the opposite direction, but it still has a one-to-one relationship for the slope. So what we have here is, let's keep blue, is y equal to a minus x minus 0. And 0 because this thing's not moving to the left or the right at all. If this x was -3, then the graph would be going in the opposite direction, be going 3 to the right. And if it were +3, it'd be going 3 to the left. And the reason for that is just like with the vertex formula, what we're solving for is what would be equal to 0. So if you have x minus 3, then that'd be x minus 3 equals 0, and you just add 3 to both sides, so you'd have x equal to 3. So whatever it is inside the parentheses or inside the absolute value bar, it's just going to be the opposite. But there's nothing in this case, so it's just really 0. It's really just absolute value of x. There's no reason to put the 0 in there. And because we're going in the opposite direction here, for negative, it's a -1, because we're flipping the v upside down. That is the parent function upside down. And then plus k, we have, in this case, we went up 2 over here, so it's plus 2. And let's just make sure of that, do a quick table. So again, put the 0 in the middle. Absolute value of 0 is 0. 0 plus 2 is, well, absolute value of 0 is 0. 0 times -1 is still 0. And then 0 plus 2 is 2. So that maps out. And then we have -1 and -2. So absolute value of -1 is +1. +1 times -1 is -1. -1 plus 2 is negative. Positive value of the absolute value of -1 is absolute value of -1 is +1. +1 times -1 is -1. -1 plus 2 is +1. For a second there, I said -1. And then 2, absolute value of -2 is +2. +2 times -1 is -2. -2 plus 2 is 0. And then 1 and 2, absolute value of 1 is 1. 1 times -1 is -1. -1 plus 2 is 1. So it's the same thing that we just had over here. And then absolute value of 2 is 2. 2 times -1 is -2. -2 plus 2 is 0. So same thing as over here. And that would check out because we're 2 and 0. We have this, 2 and 0. And x and 1 and 1. And -1 and 1. So that graph would work. It would be A. And then finally, for problem 14, this is just y equal to mx plus b, because we have y equal to -3/4 times the independent variable x plus the y-intercept b. So that means that b, where x equals 0, what does y equal? Well, in this case, 1. positive 1, which is this thing. So we have 1 over here for the point of origin, and then the slope is negative 3/4. And because that's negative 3/4, where normally the graph would go up like this, because it's negative, it's going to go down like this. Or down like this one in red. So do all that. 1 second. My green. A moment. Okay, little technical issue there, but regardless, going back to our point of origin, which was right over here. Then we're going to go down 3. So 1, 2, 3, and then over to 4. And then we're going to go up 3. So 1 plus 3 is 4, and then over 4. So then go like that. And let's see if that makes sense. If we had negative 3/4 times 4, since we're x equals 4, y equals negative 2, plus 1. Well, those 4s would cancel out, and you'd have negative 3 plus 1 equals negative 3 plus 1 would equal negative 2, so that makes sense. And then if we have over here, we went up 3 to 4. 1 plus 3 is 4. So again, if we have negative 3/4 times where x equals negative 4, well, then that's just going to be, and then plus 1. The 4s are going to cancel out, and then it's a negative times a negative, so it's going to be 3 plus 1, which equals 4, y equals 4. So there we go. Apologize for the technical difficulties, but hopefully that was helpful if there's anyone who didn't know what the answers were on those 4 problems, or if you found it the least bit enjoyable for anyone who's watching the video.